In this video, I am going to talk about the area under the normal distribution curve. More specifically, I am going to talk about these percentage values. If you look at the dotted line, as I am pointing out with the help of my mouse pointer, the area to the left of this dotted line represent 50% of the total area under the curve, and area to the right of this dotted line represents 50% of the total area under the curve. The vertical line corresponding to -1 sigma and the vertical line corresponding to +1 sigma. If we take the area under the curve between these two lines, this one and this one, that represents 68.3% of the total area under the curve. If we consider the vertical line corresponding to -2 sigma and vertical line corresponding to +2 sigma, the area under the curve between these two lines represents 95.5% of the total area under the curve. If we consider the vertical line corresponding to -3 sigma and the vertical line corresponding to +3 sigma, then area under the curve between these two lines represent almost 99.7% of the total area under the curve. Now, how do we get these percentages? That is what I am going to decode in this video. Let us get started. Here I have got a variable x, and the first thing that we should do before we proceed with our analysis is to create the descriptive statistics for x, to know about the variable x. That's the basic thing we should do to start with. So to do that, we need to go to data analysis, descriptive statistics. Okay, then we need to put the input range. So input range will be A1, Control Shift down arrow. Columns should be ticked, labels in the first row. Output range, we have to specify where we want our output to appear. So let us instruct Excel to generate output in cell H1. Summary statistics should be clicked, and then we should click OK. So that will give us the descriptive statistics for x. That x is by and large normally distributed, because skewness and kurtosis both are very, very close to 0. So by and large x is normally distributed. Once we have got this confirmation that x is by and large normally distributed, the next thing that we should do is to create bins. So to create bins, the first bin should be the minimum value of x. So minimum value of x 80.79, and then we have to create other bins by adding a bin interval to the previous bin. So for example, the second bin should be the first bin plus a bin interval. Let us assume the bin interval to be 0.01. I have kept this bin interval deliberately very, very small, so that we have the effect of a continuous distribution, right? The smaller the interval, bin interval, better it is for a continuous distribution. So for rest of the cells, we can just double click on this plus sign, and the bin values for the rest of the cells will get replicated, right? So you can see we have got all the bin values replicated, right? You have got all the bin values replicated. So we have got total 10,000 observations and we have got 10,000 bins. But I really do not require all these 10,000 bins. Why? Because my minimum value is 80.79 and maximum value is 126.82. So beyond the maximum value of 126.82, I don't require the other bins, right? So what I can do, I can just simply delete bins higher than the maximum value, right? So let us do that. 26.82. So let us skip till 126.83 and we will delete the remaining ones. Okay. Now once this is done, the next step is to generate frequencies corresponding to each bin. Now to generate frequency corresponding to each bin, we can take the help of data analysis toolpack, and in data analysis toolpack we have histogram. Using that histogram tool, we can generate the frequencies corresponding to each bin. So let us do that. To do that, go to data, go to data analysis, click on histogram, click OK, give the input range. Input range is A1, Control Shift down arrow. Bin range, we can specify the bin range, that is B1, Control Shift down arrow. Label should be ticked. Let us say we want the output to appear in C1. Click on chart output, then click on OK. So Excel is asking permission to overwrite. Yes. Some data will be hidden by embedded chart. Yes, no problem. So we get the histogram, right? You can just remove this frequency part and expand the histogram little bit so that view becomes better. So we have got all the frequencies. Now you see Excel has also generated the bins, and these bins are exactly same as the bins that we have specified. So there is nothing to worry about it. We have two columns for bins, but basically both the bin values are same, right? Now next step that we need to follow is to convert the frequency into probability. We can convert the frequency into probability using this formula: frequency divided by total frequency. Total frequency has to be the total number of observations, right? And I'll give absolute reference for the total frequency. Once this is done, I'll just replicate this by double clicking on the plus sign. Once you have done this, please cross check or verify that the total of the probability has to be 1, and you can see the sum is equal to 1. So our calculation is correct. The next thing that we need to do is to calculate the cumulative probability. So cumulative probability for the first one is the probability itself. Cumulative probability for the next one is the probability for the next one plus cumulative probability of the first one, right? And once this is done, just select this cell, double click on the plus sign, and it will get replicated, right? So if you just select this cell and then Control Shift down arrow, you can see that the last value under the cumulative probability column is 1, right? That is again the cross checking that our calculations are correct, right? So once this step is done, then we can actually calculate probabilities corresponding to different values of x, or cumulative probabilities corresponding to different values of x, we can do that. So we can do it either using the Excel function or by manually figuring out what is the cumulative probability corresponding to a particular bin value or x value, right? So here I have got the intervals, confident intervals already created for x. So first confidence interval is mean plus 1 SD, then mean plus 2 SD, then mean plus 3 SD, and then we have mean minus 1 SD, mean minus 2 SD, and mean minus 3 SD. So how to calculate this mean plus 1 SD? It's very simple. Mean is 100.09 plus SD is 5.02. Once you get this, you can get the value for this particular cell, but you need to be careful because you need to give absolute reference for mean and standard deviation. Okay, because mean and standard deviation both are constant for all other values of x, right? Once this is done, you can just simply drag it, but you have to change the formula here because here it is mean minus 1 SD. So just change the plus sign to minus sign, done, and then again drag it down. So this will give you the numbers. Now mean plus 1 SD is equal to 105.11. Now what is the cumulative probability corresponding to 105.11? So let us just find that out. 07 or 84.07%, right? 0.8407 is same as 84.07%. 84.07%. Okay. Similarly, we can quickly find out what is the cumulative probability corresponding to 110.14, 9764, that is 97.64%. Okay. Similarly, what is the cumulative probability corresponding to 115.16? So 100 is 0.9985 or 99.85%. In the same way, we can calculate the probability corresponding to cumulative probability corresponding to 95.06. So 95.06, 0.16 or 16%. Corresponding to cumulative probability corresponding to 90.04. Let us find that out. 0.0219 or 2.19%, right? So I did not select this. Yes, 90.04. This is the number. Okay. Similarly, probability corresponding to 85.01, 85.01, 0.0015 or 0.15%. We can also calculate these probability values using norm.test function available in Excel. So how to do that? We'll first take the norm.test function, x, then mean, will give absolute reference, comma SD, will give absolute reference, comma, we have to select true for cumulative. Once this is done, bracket close, press enter. Once you have done this, you can just drag it down for other cells and you will get the numbers. And you can see by and large we are getting the similar answers, right? And you won't get exactly the same answer because when we are doing it manually, we are not able to consider all the values of x because x is a continuous distribution. While constructing the bins, we are not able to take into consideration all the values of x. Naturally, you won't get exactly the same answer, but you will get close to the answer that you will get using the Excel function, right? Now, what is the next thing we'll do? We will find out what is the probability that x lies in between 95.06 and 105.11? And if you see, 95.06 is nothing but 95.06 is nothing but mean minus 1 SD, and 105.11 is nothing but mean plus 1 SD. So we are trying to find out what is the probability, or basically we are trying to find out what is the area under the curve between this line and this line. Ideally it has to be 68.3%. Let us see how much we are getting. So to calculate this, what we need to do, we need to first take the probability, cumulative probability corresponding to 105.11, that is 84.7%, minus cumulative probability corresponding to 95.06, that is 16%. So that should give us the probability that x lies in between 95.06 and 105.11, right? And that is 68.07%. Ideally it should be 68.3%, right? Similarly, if we calculate what is the probability between 90.04 and 110.14, that is what is the probability that x will lie in between 90.04 and 110.14, that will come to 95.45%. and for that, what we have to do, we have to first take the probability, cumulative probability corresponding to 110.14. from that we have to deduct the cumulative probability corresponding to 90.04, so that will give us 95.45. so basically if you see, we are trying to find out the area under the curve between this line and this line, right? And ideally that should come to 95.5%, but we are getting 95.45%, very close. In the same line, we can calculate what is the probability that x lies in between 85.01 and 105.16. that means we are trying to find out the area under the curve between this line and this line. Ideally it should come to 99.7%. let us see how much we are getting. To calculate this probability, what we have to do, we have to first take the probability corresponding to 115.16. from that we have to deduct the cumulative probability corresponding to 85.01, right? So we are getting 99.7%. ideally we should get 99.7%, and we are getting exactly the same thing. If you want to use the function and calculate these probabilities, that is also possible. So in the same line, because we have already got these probabilities calculated under this column, so we can just deduct the probability corresponding to 105.11. that is, we can take the probability corresponding to 105.11, and from that we can deduct the probability corresponding to 95.06. that will give us this number, right? And it comes to 68.27%, right? Same way we can calculate the probability that x lies in between 90.04 and 110.14. for that we have to take the probability corresponding to 110.14, and from that we have to deduct probability corresponding to 90.04, right? And if we want to calculate the probability that x lies in between 85.01 and 115.16, then for that what we need to do, we need to take the probability corresponding to 115.16 and deduct the probability corresponding to 85.01, right? And we'll get the answer. You can see we are getting by and large the similar answer, right? And this explains how we get these percentages, right? A standard normal distribution, right? And what about a standard normal distribution? Do you get the same set of values? That means mu plus minus 2 standard deviation. Does it account for 68.3%? Mean plus minus 2 standard deviation, does it account for 95.5%? Mean plus minus 3 standard deviation, does it account for 99.7%? That is what we will be verifying in the next part of this discussion. Okay, so for that, let us go to SND tab, that is for standard normal distribution. Okay, I'll delete this histogram for now and we'll generate it from the beginning. We all know about this variable x because we have already discussed, and we know there are 10,000 observations for this variable. So first we have to convert x into z, where z is a standard normal variable. That means z follows standard normal distribution. Okay, how to do that? Very simple. X minus mean of x, which I will calculate, and I will give a constant or absolute reference, divide by SD of x. For SD of x also we will give constant or absolute reference. Okay, now once this is done, you can just double click on the plus sign. Don't worry about these symbols coming, because we have not filled in the mean and SD yet. Once we fill in the mean and SD, it will be fine. So what is the mean of x? For that, average then you have to select all the values of x, Ctrl+Shift down arrow. Okay, similarly STDV of x. So you see, once we have filled in the mean and SD, we have got all the values corresponding to Z column, right? So next step is to create bin for Z. But before we create bin for Z, let us create the descriptive statistics for Z. For that, we need to go to data, data analysis, descriptive statistics, click OK. Select the input range. So here my input range will be Z values, right? So Ctrl+Shift down arrow to select all the values of Z. Columns will be ticked, levels in the first row. Output range, we have to specify where we want the output to appear. Let us say we want the output to appear somewhere here. Okay, summary statistics should be ticked and we should click OK. Okay, so that will give the descriptive statistics for Z. Now we can just change the cell formatting and we can change this general to number. Okay, now we are all set for the calculation related to bin. So first bin will be the minimum value of Z and we should go up to the maximum value of Z. So second bin should be first bin plus the bin interval. Let us take a bin interval of 0.01 and then we can just double click on the plus sign, but we should not go beyond 5.32 or you can take 5.33. So rest all we will just simply delete, not required. Okay. Next thing, we need the frequency. To generate the frequencies, we will take the help of data analysis toolpack. More so, we will take the help of histogram. So data, go to data analysis, Now histogram, click OK, select the input range. So your input range will be Z column. Your bin range, we have already created the bins, so we select the bin range. Okay, level should be ticked. Output range, where do you want the output to appear? Let us have the output in D1. Chart output should be ticked. Click OK. Excel is asking for permission to overwrite. Okay, this also you click OK. So your histogram appears, right? And we have got the frequencies as well. That is what we wanted. So you can just expand this little, right? So you get the histogram. Next step is to convert the frequency into probability. For that you have to use the formula frequency divided by total frequency. Once this is done, you can just double click on the plus sign, but here you have to give absolute reference, and then you can just double click, it will come, and you will see the total of your probability has to be 1, and that is what we are getting. Sum is 1, so our calculations are correct, right? Next is cumulative probability. Cumulative probability for the first one is the probability itself. Cumulative probability for the second one is the probability for the second one plus the cumulative probability for the first one. Once this is done, you can just select this cell and double click on the plus sign, and then you can just select all the values in the cell, and you can check the last value has to be 1, right? Because once we add up all the probabilities, the total should be 1, right? Now we are in a position to find out what is the cumulative probability corresponding to a particular value of Z. So here I have created some confidence intervals. First one is mean plus 1 SD, second one is mean plus 2 SD, third one is mean plus 3 SD, fourth one is mean minus 1 SD, fifth one is mean minus 2 SD, and sixth one is mean minus 3 SD. So let us calculate these values. Very simple. Mean is 0 plus 1 into SD. SD is 1 because we know for a standard normal variable mean is 0 and SD is 1. We have to give absolute reference for mean and SD. Once you enter, you will get this, right? You can then drag it down, and here you have to just change the formula. So change the plus sign to minus sign, you will get the number, and then you just drag it down. So good to go. So we have Z values starting from plus 1, plus 2, plus 3, then minus 1, minus 2, minus 3, right? We can now find out what are the cumulative probabilities corresponding to each of these values of Z, right? So cumulative probability corresponding to Z equals to 1 is, you can say, we have already done that. Z equals to 1 is here. Z equals to 1 is 0.8407. Similarly, cumulative, you can find out cumulative probability corresponding to Z equals to 2 is here. When Z is equal to 2, cumulative probability is 97.61. Okay, right? Similarly, we can get the cumulative probabilities corresponding to these different values of Z. So when Z is equal to 3, cumulative probability is 99.85. when Z is equal to minus 1, cumulative probability is 16%. When Z is equal to minus 2, cumulative probability is 2.19%. and when Z is equal to minus 3, cumulative probability is 0.15%. Now we can calculate these values using the norm.s.dist function available in Excel. So how to do that? Very simple. Equals to norm.s.dist, open bracket, first select Z, then comma, true for cumulative, bracket close, press enter. You just, after calculating this, you just drag it down, right, and you will get the rest of the values, correct? And if you want to calculate what is the probability that Z lies in between -1 to +1, the probability is 68.07%. How to do that? That is probability, cumulative probability corresponding to Z equals to 1 minus cumulative probability corresponding to Z equals to -1, right? Similarly, what is the probability that Z lies in between -2 and +2? That is 95.42%. How do I get that? Very simple. Cumulative probability corresponding to Z equals to 2 minus cumulative probability corresponding to Z equals to -2. Similarly, if you want to find out what is the probability that Z lies in between -3 and +3, so that is 99.7%. How do you get that? Cumulative probability corresponding to Z equals to 3 minus cumulative probability corresponding to Z equals to -3. We can use these values also to calculate these values, right? So here you can see, if you are using the norm.s.dist function, then the probability that Z lies between -1 and +1 is calculated by deducting the probability corresponding to Z equals to -1 from the probability corresponding to Z equals to +1. In the similar way, you can calculate other two values as well. Now you can see that it does not really matter whether we are talking about a normal distribution or standard normal distribution. So the area under the curve between the vertical line corresponding to -1 sigma and the vertical line corresponding to +1 sigma is 68.3%, right? Okay, so this is what we are getting. And the area under the curve between the line -2 sigma, that is the vertical line corresponding to -2 sigma, and +2 sigma is 95.5%. So we are getting 95.45%. Okay, and the area between the lines corresponding to -3 sigma and +3 sigma, right, is 99.7%, and we are getting almost the same, right? So this verifies the fact that whether the distribution that we are referring to is a normal distribution or a standard normal distribution, the area under the curve for these confidence intervals are the same, right? Hopefully you have got it. Thank you.